Hello students, the next instruction I'm going to discuss in the data transfer group is LXI RP data 16-bit. So for example, how it is written? For example, LXI H2034H, that is 16-bit data, any 16-bit data you need to write, and the register pair. So RP represents the register pair and data is the any 16-bit data you can write in the instruction. And register pair means I have told you in the 8085 microprocessor that there are various register pairs like BC, DE and HL. BC, DE and HL. Now, how you will write the register pair? How you will write the data? So in like BC, the higher byte register in the register pair, you're going to mention that register in the instruction. For example, BC, DE, HL, like in HL, the higher byte of this register pair is represented by H. Again, I am repeating, the higher byte of the register pair is represented by H. So I'm going to mention H in the instruction. So for any register pair of 8085 microprocessor, in this instruction you're going to mention that register of the register pair which will store the higher byte. And then 16-bit data can be any 16-bit data. So what does this instruction do? LXI RP data, it stores the data, since again it is I, that is immediate, it will store the operand, that is data, into the register pair. Example, LXI H2034H. So what it will do, it will store this 2034 hexadecimal number in the HL register pair, where higher byte is stored, that is higher byte, that is 20, will get stored in H, and lower byte of this hexadecimal number, that is 34, will get stored in L. So in this way, this 16-bit number will get stored in the HL register pair. Now again, this is a copying instruction. The data is being copied. So the flags affected will be nil. No flags will get affected. Number of bytes, as I've told you, like LXI H2034H, I've told you need to see for finding the number of bytes in an instruction that how many extra hexadecimal numbers are present in the instruction. For example, in this instruction, 2 bytes of hexadecimal number are mentioned in the instruction. So overall, how many bytes of instruction it is? 3 bytes. 1 byte for the opcode of the instruction, and the remaining 2 bytes will be this data, 16-bit data that is mentioned in the instruction. So all total 3 bytes instruction. 3 bytes. Next, I need to find the machine cycles of this instruction. So how many machine cycles will microprocessor need for the execution of this instruction? Example, like LXI H2034H, how, since this is a 3-byte instruction, when this instruction will get stored in the memory, it will occupy 3 memory locations. First memory location will store the opcode, second memory location will store the lower byte of the data mentioned in the instruction, and the third memory location will be used for storing the higher byte of the data mentioned in the instruction. In this way, first one is opcode, second is lower byte of the data, and third one is higher byte of the data mentioned in the instruction. In this way, 3 memory locations will be used, or 3 byte will be used for storing this instruction in the memory. Now, at the time of execution, microprocessor will first fetch the opcode. So first machine cycle is used for opcode fetch. After opcode fetch and decoding of the opcode is done, microprocessor will come to know there is certain data which is in the memory that it needs to store in the HL register pair. So second machine cycle will be used for reading the lower byte of the data, means second machine cycle is memory read machine cycle. So after reading the lower byte of the data, it will go into the microprocessor, and the next machine cycle will be used for reading the higher byte of the data. So it is also a memory read machine cycle. So in this way, the whole data will go inside the microprocessor. Once the microprocessor has the 16-bit data mentioned in the instruction, it will store that data in the register pair, whatever is mentioned in the instruction. Here H is mentioned, means that data will get stored in the HL register pair. So in this way, this instruction will need 3 machine cycles. Now how many T states? As I have told you that first machine cycle, that is opcode fetch machine cycle, it needs 3 machine cycles. First is opcode fetch, second one is memory read, and third one is also memory read. So opcode fetch machine cycle has 4 T states, memory read machine cycle has 3 T states, and memory read machine cycle has 3 T states. So all total 10 T states. So it needs 10 T states. Addressing mode. What is the addressing mode? Again, I have told you, since this instruction where the operand is directly mentioned, operand means that data which needs to get stored. Here, since it is a copying instruction, so operand which needs to get stored is directly mentioned in the instruction. The operand is directly mentioned in the instruction. Therefore, this type of instruction will have immediate addressing mode. Now, the next instruction that I will be discussing is STA-ADDR. ADDR is representing address, and STA, what does this instruction do? For example, STA2500H, since address means the address of memory location. Here address means the address of memory location, and the address of memory location is of 16 bits. So whatever you will write, it should be of 16 bits address. So what does this instruction do? STA 16-bit address, what it does, it stores the content of accumulator into the memory location, whichever is mentioned in the instruction. So what it will do, so let's just take an example. Let's the content of accumulator is 20H, and the address that is mentioned here is 2500H. So the memory location, the address is 2500H. After execution of this instruction, the content of the accumulator, this 20H, whatever be the content of accumulator, here it is 20H, it will get stored into the memory location that is mentioned here. That is 20H will get stored in the memory location. Again, one more thing I would like to discuss, as I've already told you in my previous lecture also, that what is operand? Operand is that data on which the microprocessor is going to work. For example, here, what is the operand? STA2500H, the operand is the content of accumulator or the content of this memory location. So here in this instruction, I have written STA is the opcode and 16-bit address is the operand. That is for convenience I have written. Basically, STA is the mnemonics, and the opcode of this instruction you already know, because you have the opcode list. From there you can find the opcode, and operand means the content of the 16-bit address or the content of accumulator. Whenever I say operand is a memory location or operand is a register, that means operand is the content of the memory location or content of that register. So this is all about STA address. Flags affected, again under data transfer group, no flags will get affected because every instruction will do copy from certain source to certain destination. Number of bytes, obviously, as you can see from this instruction, how many number of bytes? 1 byte for the opcode, and number of extra hexadecimal numbers that are mentioned in the instruction is of 2 bytes. So all total, how many bytes of this instruction? 3 bytes. 1 for opcode, and the remaining 2 bytes for the address or the data that is mentioned in the instruction. How many machine cycles? Okay, let's see how many machine cycles are needed. STA2500H, let's see how this instruction gets stored in the memory. So first machine cycle will be used for storing the opcode. That is, this machine cycle will be used, this memory location will be used for storing the opcode. Again, I am correcting myself. I was saying machine cycle. No, it's not machine cycle, it's memory location. So again, I am repeating how this instruction will get stored in the memory. First memory location will be used for storing the opcode. Second memory location will be used for storing the lower byte of the address, that is 00, and third memory location will be used for storing the higher byte of the address. In this way, the whole instruction will get stored in the memory. As I've told you, this instruction is of 3 bytes. So as you can see from here also, it will occupy 3 memory locations, each memory location of 1 byte. So this is the memory that is attached with the microprocessor. Now regarding the machine cycles, first machine cycle will be used by microprocessor for fetching the opcode. That is, first machine cycle is opcode fetch machine cycle. Once the opcode is fetched and decoded, microprocessor will come to know that it has to store the content of accumulator into some address. But the microprocessor does not have the address. The address is stored in the memory. So second machine cycle will be used for reading the lower byte of the address. That is memory read machine cycle. Second machine cycle, memory read machine cycle, for reading the lower byte of the address. Third machine cycle for reading the higher byte of the address. Third machine cycle is used for reading the higher byte of the address. So now the whole address is present with the microprocessor where it needs to store the content of accumulator. So fourth machine cycle, in order to execute, complete execution of the instruction, fourth machine cycle will be used for writing the content of the accumulator into the address. So fourth machine cycle is memory write, for writing the content of accumulator into the memory location that it has fetched recently. So all total 4 machine cycles. So you can see STA needs all total 4 machine cycles. Now T states, how many T states? Since it needs 4 machine cycles, 1 opcode fetch, 1 memory read, 1 memory read, and 1 memory write. Opcode fetch has 4 T states, memory read has 3 T states, memory read has 3 T states, and memory write has 3 T states. So all total 13 T states. So it requires 13 T states. Addressing mode, as you can see, the content, as you can see the operand, the address of the operand is directly mentioned in the instruction. So those type of instructions will have direct addressing mode. So it has direct addressing mode. Now one more thing I would like to discuss is that whenever if I give you any instruction, suppose I'm giving you instruction LXI RP data, or you can say LXI, suppose this instruction LXI H2034H, and I tell you to make the timing diagram for this instruction. How will you draw the timing diagram? You know LXI H 16-bit data needs 3 machine cycles. You first have to find how many machine cycles does that instruction need. It needs 3 machine cycles, LXI RP data. One is opcode fetch, one is memory read, and the last one is also memory read. So it needs all 3 machine cycles. So what you need to do, you know the timing diagram of opcode fetch, you know the timing diagram of memory read. So you will draw the timing diagram representing 3 machine cycles. First machine cycle, that is opcode fetch machine cycle timing diagram. Second is memory read machine cycle timing diagram, and the third one is memory read machine cycle timing diagram. So this will be the complete timing diagram of the instruction LXI. In this way, you can make the timing diagram of any instruction if you know the machine cycles that the instruction will need. So I'm ending this class here.